Welcome, everybody. Great to have you join me. My name is Steve Ansell. I am one of the physicians at Mayo Clinic, and I'm based in Rochester, Minnesota. And I'm speaking really on behalf of a whole team of both clinicians and scientists. Glad to be talking to everybody.
Dr. Ansell, last year, you and Dr. Zachary Hunter at Dana-Farber Institute co-developed a research proposal that IWMF decided to fund as the largest grant in our history. So what are IWMF donors funding exactly?
We're very excited about research that we're working on right now. We're actually working on a number of different strategies to have a better understanding about Waldenstroms in general. And we're particularly interested in how proteins and pathways in the cancer cell change the ability of the immune system to detect and fight against the cancer. We're finding that there are changes that make the cancer cell invisible to the environment and to the immune system, but also change the immune system to make certain cells that are effective cancer-fighting cells less prevalent and cells that are more suppressive more prevalent. So we really are trying to understand that balance because we think that's the next frontier. We want to change the environment and make the cancer cell less secure, if you like, and the immune cell and the immune system more efficient at getting after the cancer.
Dr. Ansell, as you look at this Waldenstrom's research frontier and go 2 years out, what do you envision?
I think we will have accomplished the goals, at least in part. And what I mean by that is this is a very bold initiative, and there's a lot to learn and a lot to understand. And the importance, I think, will be that we will have identified some key interactions, key proteins, and key pathways that we can then build upon and specifically target to develop treatments. So we would hope and expect that we will be able to map things out pretty compellingly and then be able to specifically see where we can make a difference and develop therapies that actually make that difference.
Thank you, Dr. Ansell. We are so glad to see Accelerate the Cure donations at work. Now we're off. Next stop is Italy. Bye.
Good morning, everybody. Actually, I'm a physician, an hematologist, mainly interested in lymphoma patients' care and research. And our aim is to understand by a simple blood test some news about patients and diseases. In particular, regarding Waldenstrom, it's really interesting to know which patients with IgM gas will proceed to an open Waldenstrom, or which patient with an asymptomatic Waldenstrom will progress to asymptomatic Waldenstrom, and so will need therapy. And it is very important to know when he or she will need therapy. So in 3 months, in 5 years, in 20 years. And still now, we have no biomarker, no clinical marker that is useful to foresee their future. So this is one of the most important things that I'm trying to understand with research.
Are you making progress?
Yes, actually, also thanks to the IWMF grants, we received 2 grants till now in the last 10 years. We developed some novel tools, very sensitive and patient-friendly. That means in peripheral blood, so without using bone marrow aspiration or bone marrow biopsy. So we are tracking some specific mutation of Waldenstrom, the MYD88 mutations, first of all, and we quantify in peripheral blood this mutation with the aim of understanding which patients will progress to an open Waldenstrom and which will remain in an indolent state of IgM gas for many, many years. The second step will be to study in the peripheral blood, in the plasma, so without bone marrow examination, to study the expression of specific genes, so the RNA expression, and to find signatures that might predict this evolution. We presented some preliminary data on RNA at the last meeting of American Society of Hematology in December in San Diego.
Thank you, Dr. Ferrero. Accelerate the Cure donations allow us to envision a future with less invasive bone biopsies. We like that. Goodbye. Off to Australia we go.
Well, hello everyone, and welcome to sunny Sydney here in Australia. It's my pleasure to be with you today.
We are so glad to see you, Dr. Trotman. Let's get started. Someone just asked, why has Waldenstrom's become an important component of your life's work?
Well, I've always been a lymphomaniac and keen clinician researcher. And I have to say, it's always great to be on a winning team, isn't it? So there was no doubt that I was inspired a decade ago by my participation in the Innovate study, introducing ibrutinib to Waldenstrom's, that game-changing first-generation targeted therapy that switched off the activity of the WM and made so many of my patients feel and live so much better. And that was followed very quickly by my experience with zanubrutinib, the next generation enzyme inhibitor studies that again transformed the lives of my patients. They were not just living longer, they were living better. And I continue to be inspired by all the novel therapies, the BCL2 enzyme inhibitor therapies and trials, the BTK protein degrader studies that just keep extending this transformational change in the way that we're treating Waldenstrom's. And it makes me a sort of a dyed-in-the-wool antibody chemotherapy purist really start to question where we will be using rituximab chemotherapy in the management of Waldenstrom's in 2027, 2030. Now a chemo-free future is a very exciting prospect. So there's so much happening in clinical research in Waldenstrom's.
Dr. Trotman, you gave a presentation at the last IWMF Ed Forum that was titled Play the Long Game. Explain what you mean when you say that to your patients.
I guess when I think about playing the long game for patients with Waldenstrom's and indeed for all indolent slow-growing lymphomas, it means that for WM, now the vast majority of patients, it's a chronic manageable disease. And with these novel therapies perhaps doubling their life expectancy, they need to decide with their treating hematologist, their treating oncologist, the best way to sequence therapies to deliver that functional cure for them. I think that needs to take into account not just the patient and the available therapies, but a bit of crystal ball gazing into the future as to what therapies might be potentially available, and also how fit you will be for other therapies in the future.
So we have another question, Dr. Trotman. What are some key points you would like patients to remember about clinical trials?
Clinical trials today are tomorrow's standard of care treatment. There's no doubt about that. They are scientifically and ethically approved ways to move the dial forward for better treatments and better lives for our patients. And all patients in need of treatment should be asking, is there a clinical trial that I should be screened for participation in? Because not every trial is right for every patient, and we need to screen everyone to recruit a few. But I definitely think, it's by grace of the clinical trials of the past that we have so much in our armamentarium to manage Waldenstrom's now. So I sound like a zealot, don't I? But I do think, good quality clinical trials underpin the advancements in WM.
Dr. Trotman, do you have closing points you might like to make about our Accelerate the Cure campaign to fund research?
I was thinking about this question, and it goes to sort of this goal of cure and what cure is, the definition of cure. And I think it's an underused and a hard to define word in WM. I think the concept in the true Latin sense of cura, to heal, to restore to good health, which is actually echoed in the NCI Cancer Dictionary. We know many patients with WM actually already achieve a functional cure, and they're predicted to die from other diseases of aging, vascular disease and other cancers. And it's become possible because of the novel agents in clinical practice and clinical trials. And so perhaps the most affirming statement for the patient who presents in 2025 is that modern survival is now so prolonged, we can't actually make reliable survival estimates. So I guess a parting point of optimism is that I urge patients to join the quest to accelerate the cure, support the quest for a cure at a disease level, but be inspired by the fact that many individual patients we have already achieved a functional cure for. And we need to focus also on how well they're living.
Thank you, Dr. Trotman. We love the visit. We're off to New York now for our next Accelerate the Cure research moment. Bye.
Hi, it's nice to see you, and welcome to all who seek a cure for Waldenstroms.
Tell us a little about the field called bioinformatics. What is this, and how are you helping us on a path to a cure?
So, bioinformatics is essentially the computational analysis of genetic data. I specialize personally in a type of bioinformatic analysis called single-cell analysis, which provides information about essentially the activity of individual cells. So we can look in individual cells and look at what types of genes they're expressing or what their epigenetic state is, which allows us a very high resolution snapshot of what the cell is doing. So in my research, which is funded by an IWMF grant, we have applied single-cell analysis to Waldenstroms and have identified two broad subtypes of the disease that have distinct molecular phenotypes and activity.
So tell me, Mr. Gagler, tell me more about these different subtypes of Waldenstrom's and what that means for a patient down the road.
So for some context, it has been known that Waldenstrom's is a disease which presents features of both memory B cells and of plasma cells, but it has been unclear how these cell types arise and how they ultimately impact the biology of the disease. So in our study, we observed that the Waldenstrom cells in only about half of the patients were primed for this memory B cell-like state in addition to plasma cell activity, whereas the other half of the patients were conspicuously lacking any plasma cell features and were in an explicitly memory B cell stage, which suggests that they're blocked in their capacity to differentiate into plasma cells. So importantly, we also identified that these patients were enriched in some key molecular regulators, which are known to suppress and inhibit plasma cell differentiation, which suggests that these regulators may be responsible for driving this blockage, but we need to confirm this with experiments. We additionally looked at the genomic data for these patients and observed that the patients who exhibited memory B cell subtypes harbored more mutations and presented with different clinical features. And we additionally observed that the subtypes utilize slightly different molecular pathways, which suggests that they may benefit from their own treatment regimens by tailoring treatments to disrupt the specific pathways of each subtype.
So how many years ahead will it be before a patient actually benefits from this knowledge about subtypes?
That's a great question. I think the work is still early in identifying these subtypes, and I think the next task is to develop a way to do it regularly within the clinic. But once that is done, I think it will be a commonly used practice because it seems pretty obvious that the subtyping is relevant for how you should treat or deal with these patients. So to be optimistic, I would probably say within 5 years, but I think that's ultimately up to the clinicians and people developing clinical trials to make a really precise prediction on that. Sure. So first, I want to thank the IWMF for helping to fund this work and for personally funding me to present my research at the most recent IWMF meeting in Prague with the Young Investigators Award. I think that this study shows us that the more we learn about the complexity of Waldenstrom, the more we are able to see opportunities to disrupt and treat it, bringing us one step closer to a cure.
Thank you, Mr. Gagler. We love the visit. Now we're off. Thursday, we are in Boston for Jan Waldenstrom's birthday.
Thank you so much for giving me this opportunity to help celebrate Jan Gosta Waldenstrom's birthday with you. He was indeed a giant in hematology, and I think we as a community should be so grateful that he really played a pivotal role in helping us define this disease. And he was only 37 years old when in 1943 he published that seminal paper that described the clinical disorder known now as Waldenstrom's macroglobulinemia. It took actually some time, since 1943, all the way to 2011, when MYD88 mutation was actually discovered. This actually finally put together a pivotal pathological genetic, mark on this disease. And that was important because a lot of people didn't really understand Waldenstrom's. They thought it was some sort of clinical syndrome made up of high IgM levels as opposed to being a distinct, pathological disease process. But also what happened in 2011 because of the MYD88 discovery, and this occurred in our laboratory thanks to whole genome sequencing that was funded by the IWMF as well as Dr. Peter Bing. It finally gave us, a target for making drugs to focus on Waldenstrom's macroglobulinemia in a very specific way. And up to that point, all we did was what we call hand-me-down therapies. We waited for, drugs to be vetted out in different diseases, and then they would be handed to us at some point after, I have to say, a lot of begging. And now look where we are. Look where we are, that we actually have a target that we're all working together, many labs across the world working together to try to target in a very specific way. And this has already paid off. We've already got, a drug like ibrutinib, zanubrutinib. There's also a number of other IBs that I can tell you about, in this short period of time. But all this has happened because of this very important and seminal discovery. And now on his birthday, what can we tell him? We can tell him that, it was him that opened up the doors that allowed now all this progress to be made possible. And I do want to share with the audience the importance of this, because I actually have one of his final manuscripts. It was given to me by Dr. Marvin Stone. And in this manuscript, which never got published, he said that it is really the discovery of the molecular mechanisms behind a disease that actually will lead to its cure. And this is what I want to share with you. We finally have a molecular mechanism. We're working very hard to exploit it, but this is what's going to allow us to get to a cure. Not hand-me-down therapies, things that we can borrow from other disease groups, but really having a very rational approach to going after Waldenstrom's.
In the past 3 years, the number of research proposals seeking IWMF funds has skyrocketed, as you know. As co-chair of the IWMF Scientific Advisory Committee, Dr. Treon, you're about to review 29 letters of intent from researchers in 9 countries at $10 million. What's this surge all about?
Well, people are excited about Waldenstrom's, and I got to say, why shouldn't they be? Think about all the progress that's been made and all the revelations that have been made. And now Waldenstrom's actually is a flagship. Because of the ability to translate all these discoveries, the genomics of the disease, MYD88, CXCR4, and other mutations which we're learning about, this is actually exciting researchers. They want to be part of this. They want to take part and help us find a cure. And we saw this when we had the workshop on Waldenstrom's, the 12th International Workshop in Prague, just a few months ago. There were over 400 investigators. And most importantly, you know what was there? 32 young investigators were part of this. 32 young investigators who submitted their work, and through a very, elaborate peer review process, were selected to be award winners. And nothing made me happier than not only to see the current generation being very active and very interested in finding a cure for Waldenstrom's, but now we have a future generation of many dedicated individuals who want to work hard to get us there. That's why I'm excited. There's just so much going on, but we are a flagship now, and we should take on the leadership and show even other disease groups how we can do it.
Thank you, Dr. Treon, for partnering with us in this campaign for Accelerate the Cure. We're off to raise more funds. Goodbye.
Thank you for being here, and happy birthday to Jan Waldenstrom.